So California formed gradually over billions of years ago through a process called subduction, which is where converging plates collide. And so the oceanic plate collides with the continental plate. The oceanic plate gets forced underneath or subducts underneath this upper layer of Earth. And as the oceanic plate here is getting forced underneath this upper layer of Earth, it's pushing magma up from the Earth's mantle and creating volcanoes, trenches, and ultimately changing the topography of the surface of the Earth. And so when this plate goes underneath the Earth's surface, it's scraping rock, it's scraping mineral, it's changing temperatures, it's creating different pressures and mineral compositions. And this process is known as accretion. So the scraping is known as accretion. And so accretion is what's going to influence these soil types and these different mineral compositions, and ultimately what's going to affect the abiotic and biotic life on the Earth's surface. So as you have all these changes from accretion and from subduction, you start getting these different geomorphic provinces throughout California. And so if you look at this image of Santa Clara Valley here, off to the west coast is the ocean, and this is the Santa Cruz Mountains here, where it's vastly different than over here on the Diablo Range. Still a little similar, but you see a big difference in different life, different strategies, different mineral compositions. So if you hike the hills of Santa Clara Valley, you may notice the soil has a rusty tinge to it. You may also notice rock outcrops grayish in color with a faint green teal coloration. That rock is serpentine, California state rock. The rock serpentine forms under low heat and high pressure along fault lines. It formed along our coast where the existing sedimentary rock underwent a metamorphic process that didn't melt the rock, but under high pressure and underwater, it changed its mineral structure. So soils form under many conditions, but there are five main factors in their formation. These are climate, topography, organisms, time, and parent material. In the case of serpentine soils, the parent material serpentinite is what makes them so distinct. Serpentinite is basically magnesium silicate. So serpentine soils are very high in magnesium. In comparison, calcium, a mineral necessary for plant growth, is in very low quantity in serpentine soils. And plants need calcium to make new plant cells, but can't distinguish the calcium and magnesium, so they take the magnesium in place of the calcium. So this causes calcium deficiency and magnesium toxicity within the plant. Serpentine soils are also very low in nitrogen and deficient in molybdenum, which are necessary nutrients for plant growth. This challenging combination of minerals and nutrients makes plant growth very difficult. Serpentine soils also erode easily, they're very thin, they drain poorly, and they can dry for long periods of time. Even so, some plants thrive in these conditions. Plants would normally be outcompeted on nutrient-rich, faster draining soils, so they have adapted to grow on serpentine soils over time.
So today we're here at Santa Teresa County Park on the Style Ranch Trail. And this is a perfect spot to get an idea of these magnesium dense soils and what's growing here and what's living here. So behind us we have Clara County Park, and that's going to be the eastern side of the Santa Cruz Mountains going into Santa Clara Valley. And so we're going a little deeper in and we're going to see what we can find. Right here we can see a nice patch of most beautiful jewel flower. And I think a lot of these seeds were very dormant in the soils. And so thanks to the large amount, oh look at this. Thanks to the large amount of rain we had, a lot of these flowers are finally showing up after several years, even in some situations, and decades. So it's really cool to see these. California buttercups, excellent. Yarrow, red, checker bloom. Catch you soon, checker bloom. Cha-cha-cha, chia sage. Blue dicks. All right. Wall of endangered Santa Clara Valley Dudleya. Far out. No picking. Here's a tidy tip. Don't pick the flowers. But this is called the tidy tip. Oh, right on. Some big berry manzanita. There's another really cool flower here. This is called the owl's clover. You got a little patch of them right down there. Here's another really cool flower unique to the serpentine soils. This one's called Serpentine leptosiphon. So this one has a... So serpentine endemics are native plants found only in serpentine soils. Approximately 45% of the plant that grows in the serpentine habitat in California are considered endangered. And these low soil mineral content and dry conditions create these harsh environments for the plants, which resulted in the plants evolving strategies to thrive, like smaller plant sizes, waxier fuzzy leaves, so they can decrease the water loss. The plants that grow here preserve despite soil-induced limitations to their protein synthesis and their photosynthetic processes. Their root networks have become highly specialized due to their inability to penetrate deeply into the rocky soils. And these adaptations allow uptake of what little nutrients are available. So serpentine plant populations are very vulnerable to changing environments, leaving them at high risk.
So, as we've seen, serpentine soils create a very unique and effective habitat for a variety of flowering plants and different forms of life, especially pollinators. Pollinators like insects, hummingbirds, moths, butterflies, and even bats. They use flowering plants in different ways to optimize their symbiotic relationships. Pollinators are responsible for pollinating over 80% of the world's flowering plants and over three-quarters of our crops. And pollinators right now are in great decline. They're in trouble. Our lifetimes don't span generations, so it may not be easy to quantitate animal populations. It just always kind of seems full enough. However, bee populations, especially, are in dramatic decline. They're threatened by a number of ecological and environmental factors that include pesticides, fungi, genetically modified organisms. So, sustaining pollinator population is vital to life on Earth. Pollinators support the food chain for wildlife. They keep our food supply plentiful and our landscapes beautiful. You can help pollinator populations by planting a native garden with brightly colored flowers and also adding a water source. You avoid using herbicides or pesticides in your lawn, garden, or landscaping. You can support organic farmers and local beekeepers, or even build a native bee nest box if you want.